Now we will look at real numbers that comes under NCERT syllabus. We have already studied the real numbers in 9th standard. So what are real numbers? Real numbers are the collection of rational numbers or rational numbers. It is either rational number or irrational number. Any number that can be plotted on a number line is also a real number that we have studied in 9th standard. We can also define real number in another way, in an informal way, such that if somebody told you to think of a number, then a number that you could think is a real number. Why we call it as a real number? That also we have studied in the earlier classes. The word real distinguishes from imaginary numbers that involving the symbol I or square root of -1, which is used for interpreting mathematical phenomena which are occurring in electrical engineering. That you will study it in higher classes. So in this section we will concentrate only about real numbers. So what is rational numbers? Rational numbers are numbers that can be written in fractional form. That is in the form P by Q, where P and Q are integers and Q is not equal to 0. The decimal expansion of rational numbers are either terminating or non-terminating, repeating, recurring. All these things we have studied in the 9th standard. So what about irrational numbers? Irrational numbers are numbers that cannot be written in the form P by Q. The decimal expansion is neither terminating nor recurring. In this section, we will study two important phenomena of positive integers. First, Euclidean division algorithm, and second one is fundamental theorem of arithmetic. If you need more detailed study about this on real numbers, then refer my previous video about number system. That you have already studied in the 9th standard. Euclid's division algorithm. Euclid's division algorithm do with the divisibility of integers, and fundamental theorem of arithmetic do with the multiplication of integers. Euclid's division algorithm is to do with divisibility integers, and fundamental theorem is to do with multiplication of integers. Here it is, divisibility of integers. This one divisibility property has many applications, theoretical and practical applications in mathematics. But in this section, we use this property to find the HCF to positive integers. We have also already studied that what's the use of HCF. HCF is used to split things into smaller groups or ordered groups, or distribute some items into large groups. For all these things we use HCF. This divisibility property of Euclid's division algorithm forms the part of the cryptographic protocol that's used in the secure internet communications that we will study in engineering subjects. That is, in computer engineering we have to study this one. How Euclidean division algorithm is used for the cryptographic protocol. In this chapter, we have to study only how to find HCF of two positive integers using Euclidean division algorithm. Then, fundamental theorem of arithmetic is to do with the multiplication of integers. It is used the prime factorization of numbers. So, this fundamental theorem of arithmetic is also called unique factorization theorem. This fundamental theorem of arithmetic, this property is used here in this section, in this chapter. This property is used to find HCF and LCM of integers, positive integers. It has many applications, like if an Euclidean division algorithm. It has also many applications in mathematics, in factorization, permutations and combinations, etc. In this chapter, we use the fundamental theorem of arithmetic is to prove two important properties. One, nullity of these numbers, and second one, to explore when exactly the decimal expansion of a rational number is terminating or non-terminating recurring. That is, we have seen that the rational numbers, the decimal expansion of the rational numbers is either terminating or non-terminating recurring. Here the fundamental theorem of arithmetic is used. Explore how, when the decimal expansion is recurring and when the decimal expansion is terminating. So these two properties, these two concepts are proved with the help of this one fundamental theorem of arithmetic. Before we go to the subject, let us briefly look at a difference between HCF and LCM. Let us briefly look at the difference between HCF and LCM. HCF is highest common factor. LCM is lowest common multiple. First HCF. Take two numbers, 4 and 6. What are the factors of 4? 1, 2, 4. 6. 1, 2, 3, 6. 1 is the factor of every number. So, what are the common factors between 4 and 6? Highest common factor. Here it is 2. Am I right? So, 2 is the highest common factor of 4 and 6. HCF is always less than given numbers. Then, lowest common multiple of 4 and 6. What is it? We can see that 12. Am I right? So LCM of 4 and 6 is 12. LCM is always greater than these two given numbers. HCF is always less than or equal to the given two numbers. You have studied how to find LCM and HCM prime factorization in the earlier classes. Now we will look Euclid's division algorithm.